Okay everyone, today we're going to talk about Radian Measure, which is another way to measure angles. You guys are very comfortable with measuring angles in degrees. You've been doing it for a very long time. But most angles are measured in radians, and there's several reasons why that we'll discuss later. I do want to note that on my website there is an illustration of Radian Measure that is really excellent, and I think you should definitely go and check that out if you haven't already before you watch this lesson. You're going to be fine if you just watch the lesson, but it's just a really neat illustration that I think you'll enjoy. So angles that are measured in radians are no longer measuring that rotation that you're so used to thinking about. So we're really used to looking at angles that are in standard position in a coordinate plane. They begin here at the positive x-axis with my initial side, and then we're measuring this rotation. So what I'm drawing right now, that would be 360 degrees. But what a radian does is a radian measures the length of the arc between the initial side and the terminal side where it intercepts this arc. So here I have a picture. 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc of length r. So if my initial side, here this is still my origin, here's my initial side, and I'm letting this be 1 unit and 1 unit, so I'm looking at kind of a unit circle here where I have a radius of length 1. If I were to go out and measure this piece right here, this arc, so that it is also 1 unit, here's my terminal side right here. This is said to be 1 radian. So again, a radian is measuring the length of the arc and not the rotation that you're used to per se. So let's discuss circles for a minute. So the circumference of a circle is equal to 2 times pi times the radius. So you guys remember this, circumference equals 2 pi r from geometry. Therefore, if I am looking at a circle of radius 1, so I have a circle with a radius of 1, that would mean the length of this arc right here, the circumference, would be equal to 2 times pi times 1, which is 2 pi units. Therefore, there are 2 pi radians in a full circle. All right, so what we just did here is we said if I have an angle of 360 degrees, that is the same thing as 2 pi radians. 360 degrees is equivalent to 2 pi radians. This is similar to measuring 1 foot is 12 inches. Just unit conversion, different units. 360 degrees is the same angle as 2 pi radians. Well, if 360 degrees is 2 pi radians, what would 180 degrees be? So here, 180 degrees. Well, if 360 is 2 pi's, well then 180 degrees must be half of that, which would be 1 pi. And this is the conversion I'm going to use most frequently. 180 degrees is equal to pi radians. Now, one of the reasons that radians are a preferred measure is because the numerical values are smaller. Think about what 2 pi is. Pi is an irrational number, so I know it's going to be a non-terminating and non-repeating decimal. But 2 pi is approximately 6.283. Whereas pi, you guys are probably really familiar with that one because you were probably told to approximate it using 3.14 for a long time. But I can go out a few more. 1, 5, 9, ... Never ends, never terminates, never repeats. So if I was going to perhaps graph my sine, cosine, tangent functions, which we will do later on, and I'm looking at angle measures being my independent variable, my x, would I rather input 360 and go out 360, or would I rather input 6? Well, the 6 is going to be a lot easier to work with here, and so that's why Radian Measure is so much more popular than degrees, because the numerical values are easier to work with. And there's a lot of patterns with the radians too that you guys are going to see later on. But for right now, let's just get comfortable with what a radian is and how to convert in between radians and degrees. All right, so let's talk about converting. You guys are really comfortable with converting, hopefully, because you've been doing it for a long time. So let's say I have a degree measure and I want to change it into radians, and I'm going to make up an example. Let's do 120 degrees. So first, let's graph 120 degrees in standard position. So here's my initial side. My terminal side is going to be here in the second quadrant, 120 degrees. So if I want to convert this into radians, well, I know my conversion is going to be 180 degrees is equal to pi radians. So for the conversion purposes, you would have 120 degrees, which is understood to be over 1, and then I need to multiply by this conversion, and I want the degrees to cancel. So therefore, my degrees will have to go on the bottom with my radians on the top. So whenever I multiply this out, I have 120 pi divided by 180, with my degrees canceling out. And now I need to simplify this. So I can see my zeros will cancel. So I have 12 pi over 18. And now a 6's will cancel out of that. So I will pull a 6 from both the numerator and the denominator, giving me 2 pi over 3. So think about what this is saying. This is saying 120 degrees is equal to 2 pi over 3, or radians, or 2/3 of a pi. And this should hopefully make sense. If we know that 180 degrees, I'm going to draw it right here, is equal to pi radians, well, 120 is 2/3 of 180. If I were to break this 180 degrees in chunks of 60, you would have 60 degrees here. Another 60 degrees lands me here at 120. And another 60 degrees lands me at 180. So 120 degrees is 2/3 of a pi. 60 degrees, without even doing any conversion, you should hopefully see that's 1/3 of a pi, or pi over 3. So you can see how this is really nice. But if you're looking for just an algorithm to follow to convert degrees to radians, you're going to take your degree and you're going to multiply by pi over 180 degrees. The degrees will cancel and you'll simplify to get your radian measure. Now let's talk about how to go from degrees to radians. And again, we're going to do this with an example. I think what I'll do here is something in the fourth quadrant. Let's do 7 pi over 4. I like it. Let's do 7 pi over 4 radians. Let me draw a little barrier here. Okay, so first, if I'm going to graph 7 pi over 4 radians, I kind of want to know, well, how many pi's is that? So let's consider 7/4, and let's turn that into a mixed number. 4 goes into 7 one time, and then I have 3 left over. So 7/4 is 1 3/4, meaning I've got 1 pi and then 3/4 of a pi. So if I was going to graph this angle, first go out your 1 pi. That's 1 pi right there. And then you need to go 3/4 of a pi. You're not going to 2 pi. Remember, one full rotation would be 2 pi units. Half this rotation is pi. So down here, this would be 1.5 pi's, or 3 pi over 2. So I need to go 3/4 of a pi. Well, 3/4 is bigger than half, so I'm going out past a half. And then I'm going half of the way through quadrant 4. So this would be 7 pi over 4 radians. So if I want to convert that into degrees, just using a conversion, you would start with your radian measure. And using my conversion up here, this 180 degrees is equal to pi radians. I need to cancel the radians and be left with degrees. So my radians will go on the bottom, and my degrees will come on the top, and then my numerator. Notice now my pi's will cancel out. And I'll be left with 7/4 times 180. I definitely think that you should cross cancel if possible. And if I take that 180 and divide by 4, I can pull a 4 from both, giving me 45 here. So that's going to help. And my degrees, obviously, are not canceling, just the 180. So this turns into a 1. So now I'm just left with 7 times 45, which is, let's see, 315 degrees. So 7 pi over 4 is equal to 315 degrees. And think about what this actually is saying. This is saying if I were to split 360 degrees into groups of 45, that would be 45 plus 45 more is 90. This is saying right here when I'm doing this, it's saying I need 7 groups of 45. So I've got 1, 2, 3, 4, 5, 6, 7 groups of 45, which is 315 degrees. If I were to go one more group, an 8th group, that would lead me here to this 360 degrees, or 2 pi here if I had all 8 groups. So here's my conversion if you're looking for how to do it. Radians to degrees, you multiply by 180 degrees over pi radians. And that would be an algorithm that you could use. What I really want to do, though, is I really want to get you guys thinking and seeing the relationship between degrees and radians, and I really challenge you to try and work with the radians as much as possible. I'll have a lot of students who want to switch radians to degrees immediately and just work with degrees because that's what you're comfortable with, and I understand that. But the radians, once you force yourself to work with them, you'll see that you understand how to use them and that you are more comfortable with them, and in part you're going to be more comfortable with fractions overall, which is just going to be a positive thing. Okay, so what we want to do here is we've been given 3 angles in degrees. I want to sketch the angles in standard position and then convert them into radians. And so you can do this one of 2 ways, by using the algorithm where you're multiplying by pi over 180 degrees, or you can do it by sketching the angle and trying to think of how many pi's you have, and trying to think of it that way. And it's up to you, it's a preference. All right, so in the first one we have 300 degrees. So let's go ahead and sketch 300 degrees. So 300 is going to be past 270, but not quite to 360. So here is 300 degrees. So now if I convert this into radians, I'll take 300 degrees and I'll multiply by pi over 180 degrees. Seeing my degrees will cancel, leaving me with 300 pi over 180. That's understood to be over 1. And now you're going to simplify, so you can see how you have these zeros are going to cancel. I'm going to be able to pull a 2 right away, so this 30 will turn into 15, and this 18 will turn into a 9. And then they both have a 3 in common, so let's pull a 3, and I'm left with 5 and a 3. So final answer, 300 degrees is equal to 5 pi over 3. Thinking about what this is saying you have 5/3 pi's. So if I were to think about 5/3 as a mixed number, that's 1 2/3. So this is saying you've got 1 pi plus 2/3 of a pi. So if you think 1/3 is 60 degrees, another 60 degrees, I know that this right here, just this chunk, is 120 degrees, or 2/3 of a pi. So this is making sense as I check behind myself. Good. All right, next we have 145 degrees. I'm going to draw some barrier here. All right, 145 degrees. So 145 degrees is going to be in quadrant 2, so past 90 but not quite to the 180. And when I convert this into radians, I have 145 degrees times pi over 180 degrees. So when I cancel my degrees, I'm left with 145 pi over 180. Now I can pull a 5 from both 145 and 180. So let's go ahead and do that. So when I pull the 5 from 145, I'm left with 29. 29 is a prime number, so I'm noting that. And then when I pull the 5 from 180, I get a 36. Not a prime number, but I do know that that doesn't simplify anymore because 29 is prime. So I have 29 pi over 36. All right, so think about what this is saying. This is saying I have 29/36 of a pi. And 29 over 36 is bigger than a half, but it's not quite to 1. But it means if I were to break from 0 degrees to pi degrees into 36 little chunks. So 1, 2, 3, 4, and so forth. This right here, half of a pi would be 18 pi over 36. And this is pi, so it would be 36. Oh, I don't know what I just did. I just pressed something. Okay, I figured out how to undo that. Okay, so again, it'd be 18 pi over 36 at half a pi, and this would be 36 pi over 36. This means I go through 29 of them. So from 18 to here, this is 29 pi over 36. Here, that's what I'm doing. So picture 36 slices going from 0 to pi, and you are going 29 of them, and that's 145 degrees right here. 145 degrees is equal to 29 pi over 36. All right, the last one is negative 970 degrees. So right away, I know I'm rotating in the clockwise direction. And I also notice that that angle is pretty large. It's going at least one rotation, most likely two. So let's go ahead and do some math over here. Let's do a little barrier. Let's take 970 and subtract 360. And that leaves me with 610 degrees. So that's one rotation. One. Let's subtract 360 again, because it's going to be bigger than that rotation. And I get 250 degrees. All right, so let's go around again. And now I need to go 250 degrees. So going in this direction, it's 90, 180, and I need to stop at 250 degrees, which is going to land me in quadrant 2. So now converting this into radians, I'm going to have negative 970 degrees times pi over 180. So my degrees will cancel. Let's go ahead and cancel the zeros. And I am left with negative 97 pi over 18. And I believe 97 is prime, so that is it. So negative 970 degrees is the same thing as negative 97 pi over 18. Okay. So there's some practice converting from degrees to radians. And now we should do the opposite, where I've got these angles are given in radians, and I want to convert them into degrees. And let's try and sketch the angles first using the radians before I convert. So the first one is pi over 6th, 1/6 of a pi. So think about, this is 0 degrees and 0 radians. Up here is 90 degrees, or half of a pi. That's pi over 2. And then this is 180 degrees, or 1 full pi. And I'm saying I have 1/6 of a pi. Well, 1/6 of a pi is going to be very small, right? Very, very small. It's not up to a half. It's going to be just 1/6. Picture chunking this out into 6 slices. So you would have 1, 2, 3, 4, 5, 6. Each of them being 1/6 of a pi. So there it is right there. Pi over 6. And if I convert this, I would take pi over 6 and I'd multiply by 180 over pi. My pi's cancel, leaving me with 180 degrees over 6, which is just 30 degrees. And think about this. So you'd have, I'm done with this example. I've converted it and I'm done. But think about the pi over 6. If you go out another pi over 6, you'd be at 2 pi over 6. And that would be another 30 degrees. That simplifies to pi over 3. And 30 plus 30, that'd be 60 degrees. And we'll just go one more. If you were to go out another pi over 6, you'd be at 3 pi over 6, which simplifies to pi over 2, or 60 plus 30 is 90 degrees. Okay, so I'm done with that example. And let's do the 3 pi now. All right, 3 pi's. This one will hopefully not be too bad. So 3 pi's means you are going to go out 1 pi, 2 pi's, 3 pi's. So there's my terminal side right there. If you were to convert this, you're taking 3 pi, which is understood to be over 1, multiplying by 180 degrees over pi radians. Notice that your pi's are going to cancel. Nothing else cross cancels. And then 3 times 180 is going to be 540 degrees. So 3 pi is 540, or 180 times 3. Again, 180, 180, 180, or pi, 2 pi, 3 pi. Excellent. All right, so now let's take a look at the next two examples. I've got 5 pi over 3. So think about 5/3 of a pi. 5/3 is 1 and 2/3. So if I'm going to graph this in standard position, you're going out 1 pi right here, and then you're going out 2/3 of a pi. So if I were to split from pi to 2 pi in chunks of 3, you'd have 1, 2, and then 3 equal chunks. You're going out 2 of them. So this right here is 5 pi over 3 radians. If I want to just go straight and convert, I would do 5 pi over 3 times 180 degrees over pi. My pi's would cancel, and I can cross cancel this 180 and this 3. I can pull a 3 from both. If I have 5 times 60 here, and 5 times 60 is just going to be 300. That looks right. And if you were to chunk this out in just groups, if I were to chunk the groups of 3, think of it this way. If I were to go 1 pi over 3, I'm here, 2 pi over 3, 3 pi over 3, 4 pi over 3, and then 5 pi over 3 where I landed. And we know that this is kind of telling me that 60 degrees is one chunk, so this is 60 degrees, 120 degrees, 180 degrees, plus 60 is 240 degrees, and then there I am at 300 degrees. Go out 60 more, you'd be at 6 pi over 3, which is 2 pi, which would be my 360 degrees. All right, last example, negative 3 pi over 4. So here I'm going negative 3/4 of a pi. I'm not going a full pi, so I'm just going 3/4. So if I were to split from 0 to, this would be negative pi right here, into groups of 4, you'd have 1, 2, 3, 4, if I'm starting here, of course. So you're going 3 of them. This right here would be negative 3 pi over 4. And now let's convert this. I would have negative 3 pi over 4 times 180 degrees over pi. My pi's are canceling. And then 180 and 4 will simplify to 45. So I pull a 4 with 45. And think about what this is saying. This is saying you've got 3 groups of 45. So if I take 3 times 45, I get 135 degrees. And of course, I'm rotating in the negative direction here. So negative 3 pi over 4 is equal to negative 135 degrees. All right, so now we're done converting from radians to degrees. And in this last section, what I want to do is I've given some radian measures. We want to sketch the angle in standard position, and then we want to find 3 angles that are coterminal. One of them needs to be negative, and the reference angle. We're going to try and complete these exercises without converting to degrees because you guys did that in lesson 3.3, and I know you're comfortable with degrees. So we're going to try and stay in radians the whole time. Okay, so this first one is 11 pi over 6. So let's take a look at 11/6 of a pi. Let's change that into a mixed number. And that gives me 1 5/6 pies. So when I am sketching this angle in standard position, here's my initial side. I've got 1 pi and then 5/6 of a pi. So really close to a pi, but not quite. So this will be 11 pi over 6. I'm going to go ahead and do the reference angle first. Remember, reference angle is terminal side to x-axis. So if 1 full rotation is 2 pi units, that would be the same thing as 12 pi over 6 if I was comparing in terms of pi over 6. So what would be that little chunk there? It would just be 1 pi over 6. So there's my reference angle. All right, now I need to find coterminal angles. So remember, coterminal angles are angles that have a terminal side that's going to coincide. So the negative one, I think, is pretty simple. If I rotate in the negative direction, I'm just going to get a negative pi over 6 because I've already established that that little piece right there is pi over 6 radians. Now, remember when we were working in degrees, we added or subtracted 360 degrees to find coterminal angles. Well, since 360 degrees is equal to 2 pi radians, I can add or subtract 2 pi radians to the initial radian measure, and that's going to get me even more coterminal angles. So let's take a look. Let's do 11 pi over 6 plus 2 pi units. I have to have a common denominator to add, so if I change this 1 to a 6, this 2 changes to a 12. So 11 pi plus 12 pi's is going to be 23 pi's over 6. If I were to subtract 11 pi minus 12 pi, I get the negative 1 pi over 6, which I got from using logic earlier. So that 23 pi over 6 would mean go around, that's 2 pi, and then go around the 11 pi over 6. If I wanted to get another one, so let me box that. I can box this. If I wanted to get another set, I could take that 23 pi over 6 and add 2 pi again. So again, you need a common denominator. And now if I take 23 pi plus a 12 pi, I end up with a 35 pi over 6. So if I take 35 pi over 6, that means I'm going around twice. 1, 2, and then I'm landing here. So there I have 3 coterminal angles now, one of which is negative. And again, I can have an infinite number of coterminal angles. I will just keep adding 2 pi or subtracting 2 pi, and I will keep getting more and more and more. So now let's look at the next one, 4 pi over 9. So first, let's sketch this angle. So if I'm thinking about pi over 9 units, this would be 0 radians, this would be pi, which is 9 pi over 9. So here would be 4.5 pi over 9, if it's half of a pi. So that helps me see that 4 pi over 9 is going to be a little bit before that. Here's 4 pi over 9. The reference angle is easy to see because terminal side to x-axis, since this is just in the first quadrant, my reference angle is just 4 pi over 9. And now I can get some coterminal angles. So what I'm going to do is add or subtract this 2 pi. So I'll take 4 pi over 9, and I can do this in one step. Add or subtract 2 pi. Common denominator would change this 1 to a 9 and this 2 to an 18. So if I add 4 plus 18, I get 22 pi over 9. So that angle right there would mean I go around once and then I land on that terminal side. If I subtract, I'll take 4 minus the 18, which is a negative 14 pi over 9. And that would be the angle where I'm rotating in the clockwise direction, going like this. So there's 2 coterminal angles. But it says I need one more, and it said one needs to be negative. Well, I've already got one negative one. So let's take that 22 pi over 9, and let's add one more. We've already done the common denominator work. So now I'm going to have to add 22 plus the 18. And when I do that, I get 40. So there's another coterminal angle. And in that angle, I would be going around 2 times and then landing at that same terminal side. All right, let's do one more together, and then you're going to do one more on your own. So, all right, 5 pi over 3. So when I'm graphing that, I take 5/3, and let's change that to a mixed number. And I've got 1 2/3 of a pi. So when I graph this, I've got 1 pi and then 2/3 of a pi. All right. So now, terminal side to x-axis from my reference angle, I know that if this was 2/3 of a pi, I have to have 1/3 of a pi left over. So that would be my reference angle right here. And just splitting that up again, this is 1 pi. And then this right here, from here to here is 2/3 of a pi. When I add those together, I get 5 pi over 3, meaning I need 1/3 of a pi left to get to this 2 pi. And if it helps, we can write that as 6 pi over 3 to help you see that there's 1/3 of a pi remaining. Now for coterminal angles, I'm going to take the 5 pi over 3, I'm going to add and I'm going to subtract 2 pi over a 1. Getting my common denominator of 3, it changes this 2 to a 6. So I can see I've got 11 pi over 3 when I add, and I get negative pi over 3 when I subtract. So there's 2 coterminal angles. And you could have seen the negative pi over 3 kind of like in the first example just by rotating down. Since the reference angle here is pi over 3, you know, if you rotate negative pi over 3, you'll land on that same terminal side. So there I've got one negative. Let's find one more positive. So change this to a 3 and a 6, just like I did before. And then when I add these together, I'll get 17 pi over 3. So there's 3 coterminal angles. So now what I want you guys to do is one on your own, and this is the last one of the lesson. Go ahead and pause the video, and then when you come back, all the work will be shown, and you can see if we've got the same answers. Remember, you need one reference angle, and you need 3 coterminal angles, one of which is negative. Okay, welcome back. So whenever I drew the angle negative 3 pi over 4 radians, you end with your terminal side in the 3rd quadrant, since you're rotating in the negative direction. And if this is negative 3 pi over 4, and my reference angle is terminal side to x-axis, you would need 1 pi over 4 in order to get up to this x-axis right here. So that is why my reference angle is pi over 4. Then to find some coterminal angles, I added and subtracted 2 pi from the original angle, giving me 5 pi over 4 and negative 11 pi over 4. And then I went ahead and I added one more rotation to that 5 pi over 4 to get another But to recap, there's an infinite number of coterminal angles. There is only one reference angle for every angle, but there's an infinite number of coterminal angles. And I also wanted you to notice something. I specifically chose these examples because when I look at the original angles, oops, that's not what I wanted to use. When I look at the original angles denominator and its reference angle, I see a pattern. So let's go through and look at number 4. You notice that for the reference angle. Let's look at number 3. See, the original angle was 5 pi over 3. My reference angle down here is pi over 3. 4 pi over 9. My reference angle was 4 pi over 9. Again, I used the wrong thing. I just wanted to use the shadow. Let's get that back. So I notice that. And then here, for 11 pi over 6, I notice my reference angle is also 11 pi over 6. So that's just something, like a pattern, that we're going to notice, especially as we begin to go to the unit circle and look at reference angles. You're going to see that more and more. So now you're all set, and you should be good to do problem set 3.4.